Hey, everybody. Welcome. I'm here with Pamela Fox. Hey, Pamela.
Hey everyone.
And today we are going to build a RAG application on Postgres from scratch. What does that mean? Maybe we could just start there. What are we building here today?
Yeah, so we're doing RAG, which stands for Retrieval Augmented Generation. It's probably the most popular technique used with large language models these days, like with the GPT 3.5 and 4 and 4.0 and all the new ones coming out. And the idea is that we want an LLM to answer a question accurately. And the best way to get a LLM to answer a question accurately is to actually give it the information that it needs.
Give it the answer that you want.
Yeah. And what it'll do, it's like, imagine it's like, instead of us having to do a Google search or a Bing search and looking through every result and like trying to synthesize the answer in our head that we're looking for, we're using the LLM to do that answer synthesis for us, which is nice because it's annoying to have to look through 10 different sources and come up with the answer yourself. So the general way that it works is that, we get a user question, right? Like, so this is maybe for like an outdoor products website. So what's the best shoe for hiking? And then we use that question to search some sort of database, search engine, vector store, something that has the information in it. And we get back the results. And we'll get back maybe between like 3 and 10 results. We don't want to get back too many results because we don't want to overwhelm the LLM. We want to get just the right amount of results where it has the answer but it doesn't contain confusing non-answers. Then we send the user question and those results to the large language model with a system prompt that says, hey, answer the question and stay on topic, stick to the sources. If the answer isn't in the sources, just don't answer. And so then we, get an answer. And sometimes the answer is just, I don't know, because it's not in the answer. So that's the idea of RAG, is the ability to get it to answer something correctly based off our own data. So an answer in one app will be different from an answer in another app because, of course, they're going on different data sources.
This is awesome because I feel like this is the first thing people try to do when they want to use an AI to do something actually helpful. It's the thing I try to do. So I'm excited to learn how we're going to do this.
Yeah. So the interesting thing about RAG is that here it seems somewhat simple. The devil's really in the details, but there's a lot of different ways that we can build a RAG application, right? So the first thing we have to decide is, what is our search engine going to be? And ideally, it should be something that supports doing both a full text search and also supports doing a vector search, which is also called a semantic search sometimes. And that will basically take care of all of the questions that people might be asking, right? So that's what we're looking for, something that can really do very powerful searches. And I've used a bunch of options for this search. I've used Azure AI Search a lot. It's a very good search engine and it's kind of RAG optimized. So it works really well. But I've also used Postgres with the PG vector extension. So that's what we're going to be using today, because it's very easy to get started with it and you can try it locally inside VS Code, which of course we love.
I do like VS Code quite a bit. Let's do it.
So this is my PG Vector Playground, which is a repo that has a dev container that sets up Postgres and PG Vector for me. And I can just easily make a GitHub code space from it. So I'm going to click this button to create a code space. And what it does is it opens a VS Code in the browser. So it's basically like we've got the VS Code editor, the front end, and then it's running the actual code in like a Docker container on GitHub servers. That's how I like to think of it, at least. I think that's correct.
Yeah, that's totally right. As far as I understand, I noticed also that this is a template repo. So people will put the link in the description. And if y'all want to follow along with this video, you can just click the use this template button up there in the corner and create a new repository on your own GitHub and then open it to Codespace, because code spaces are free for everyone, y'all. I think you get like 30 hours a month,
Mhm.
right? I believe that's the case.
I think you get 60 hours a month. I'm actually
60.
I'm over my quota this month because I'm a little bit of an addict. All right, so here you can see that the code space looks like it's mostly built and might be still doing a little bit of extension setup. We'll start to see like extensions come in here on the sidebar. But just looking around, what we have here is there's the dev container, which sets up the Postgres. And if we look at the port, we can actually see port 5432. That is the Postgres port. That's the default Postgres port. So Postgres is actually running inside this container. And we've set it up with these, it's on localhost. The admin user is admin. This is the password. This is the database name. So what I can do is actually copy this .m file into just a .env, and so that's easy to reference. So that's my connection to the local database. And then in my requirements.txt, I have various Python packages that make it easy to connect to Postgres. Now we don't have to use all of these. They're just in this requirements in case I want to use them. But basically like psychopg2, that's one of the most popular Python drivers for Postgres, and will allow us to connect to the local database and run SQL commands in it.
The Python package names crack me up. I thought JavaScript was interesting. Python is a new thing.
Yeah, I don't know why it's called Psycho.
The JavaScript package for SQL Server, I think, is called Tedious, which it's like, why? Great package though.
Yeah, these are all great packages. So what we're going to do is that Burke actually gave me some data for the vscode channel of all the videos. So I'm going to go ahead and put that database dump file. So this is a dump of a Postgres database. It has this lovely extension .dump. And we can use
Is that a valid extension, the .dump extension?
Okay. This is the official one, yeah. So we can use it to restore a database, right? So I'll just ask Copilot, like, how do I restore from video backup.dump using .env variables? Let's see, because I actually haven't done a lot of I'm somewhat new to Postgres, so I don't have all the commands memorized, and I like to use GitHub Copilot to tell me exactly how to do stuff. So there is a command to like load the environment variables into the session. I guess hopefully that works. So if I echo db user, yeah, that looks good. Okay, and then this is the command to restore from the dump file. So it's just
that's interesting. You actually in your command you said dumb. I believe you misspelled dump, but it fixed it. I was watching. I was like, is it going to catch that?
That's very good of it. Yeah, I did say dumb.
There you go. So this is that. I mean, Copilot doesn't care if you spell things correctly, which is kind of interesting. And also, by the way, y'all, this dump file that I got for Pamela from the YouTube API, Copilot wrote that too. So I'm just being full transparency.
Nice. All right, so let's try this PG restore. Okay, and it wants the password. So I guess it decided it shouldn't put the password in there, which is fair. So I'll just go put that in. Okay, so it said it created the vector extension. That's the PG vector extension. It created the videos, and then it added the videos. So let's go ahead and look at the videos. I've got the SQL Tools vscode extension, which is a nice way to look at local Postgres databases. So
nice. Like a PG admin right in your sidebar.
Yeah. Yeah. The funny thing is I've never used PG admin because I always use SQL Tools.
Oh, really? It's that robust? That's nice.
Well, for what I use it for. Yeah. So here we can see we've got the YouTube IDs, right? These look like those beautiful YouTube IDs we all know and love. Then we've got the titles, how to be a professional unwrapper. I'm going to guess that was one of your videos, Burke.
Yeah. You got me.
And then we have descriptions, right? And for the shorts, the description is always just #shorts.
Sometimes they're just hashtags. Yeah, I actually tried to filter that out, but I couldn't get Copilot to do it.
I see. All right, so here we've got lots of fun videos here. Okay, so that is loaded up. So then the next thing we're going to do is write some Python. So let's do a new Python file, rag.py. All right, and let's just describe what we're doing at the top so that it helps Copilot give us better hints. So we're gonna get maybe like set up Postgres connection, get question from user, use question to search Postgres table, and then format the results in an LLM friendly way. And then finally send the results to the LLM, and then we'll have our answer. Okay. So that's what we want to do. Now for setting up the Postgres connection, since there's already examples in here, I'm just going to grab from my examples because I always have these examples here. So I'll just grab all this stuff here. So what we're doing here is bringing in some packages. We're connecting to the database using those values that are in the .env. So these are the same ones we use to do that restore. And so we connect to that local database. And we also set up the PG vector extension so that we can use it later if we want. All
And
right.
I assume you've added this comment at the top, not just so for the sake of presentation, but also to give Copilot some hints on what we're doing here.
Yeah, I like to set the scene so
Yeah.
that it's, it will give me more helpful instructions, right? So the next thing is
That's a very powerful tip, is to do that at the top of your file, because ghost text is a very useful way to use Copilot, and doing that keeps it within the bounds of what you're doing. Otherwise, it has no idea and will just try to infer from the code you've already written.
That's right. So for the question, we're actually going to start with a not question. We're just going to start with the word Python. The user just wants Python videos, right? We're going to build the complexity of the question and use the question to search the Postgres table, right? So I'm going to start using the like operator, right? This is like, this is like on title description, right? So this is the operator that we have on a lot of SQL databases, where it's doing a really basic.
It's like a fuzzy.
I don't even think is it even fuzzy. I don't even think that it's fuzzy.
Yeah.
Let's see if this. We'll see if this works.
Very greedy. What's the right word?
I think it's just doing like just looking for just that one word, right?
Okay. So it's like an exact match.
So this one, so see how this is kind of formatted funny, but you see how this is between percentages. So when it's between percentages, it means that it can find the word anywhere in this string. You can you put the percentages based on where you're okay with. Think of this as like stars, right? So because there's a percentage here, there could be anything before that word. And because there's a percentage here, there could be anything after that word. So this is finding it anywhere there. If you wanted to do like starts with, you would just get rid of that percentage. Or if you wanted to do ends with, you would get rid of that percentage.
So Python just anywhere in any form, even if there's no space before or after it.
Yeah. This is very jank. We're gonna make it better. Don't worry. All right, but let's see if we can get some. Let's see if we can get some results with that. Let's just making sure our connection works here. Okay. All right. Yeah. Well, it made up our database name, right? So things are going to be a little rough at first.
Yeah.
Okay. So it got stuff. Let's print out something like for result and results. Let's just print out the title. Yeah.
And these are vector results, I assume. That's why they look like this and not like text.
Well, actually, it was just because of what it happened to be showing. It was showing the entire row. And the truth is that I put embeddings in those rows. And I wasn't going to show you yet, but it revealed my truth. I've already embedded the rows so that we can use those embeddings later. All right.
And what are embeddings? Should we get into that?
Yeah, let's get into it now. Okay, yeah. I was trying to hide it, but I didn't manage to hide it. All right. So
terminal betrays you.
If we go back here, we see ID, title, description, and then embedding. So I went ahead and already computed the embeddings, and I did it ahead of time just because it takes a little bit of time, and didn't want you to have to wait for that. But basically, I went through each row and then computed an embedding for each of the rows. So what I did was that I put the title and the description together, and then said, "Hey, make an embedding for this." Wait, I have the code for it. Let me just show the where let me find the code for how I did the embeddings so that you can see that. Here we go. All right, and I just put it in a public gist so people can check it out. So I'll probably use it for other stuff too. But basically, right? So I add the embedding column. I add an index, which is how we can do efficient search on a vector column, because otherwise it's not going to be very efficient and it'll be quite slow when we're doing, searching across lots and lots of rows. So we do want an index that is optimized for vectors. This is using the HNSW algorithm, which stands for Hierarchical Navigable Small Worlds. And it's a pretty cool algorithm. It's a mouthful, but it is a cool algorithm that you can read more about. And then I just went through each video, and I used Azure OpenAI in order to make an embedding. And I decided to make an embedding of both the title and description, because I think both of those contain interesting things that we want to, search on, right? Search semantically on. And then I get back the list of floating point numbers, and I updated the embedding.
So
So
why can't
yeah.
we just search on the text here, Pamela? Like, why do we even need this embeddings?
So the reason that we like to be able to do vector search in addition to text search is that it can help look for semantically similar concepts, right? So imagine we have a title and description, and it mentions Postgres and then never says the word database, right? So then if we searched for database, we wouldn't find that Postgres video. But if we do a vector search and we search for database, then we'll find that Postgres video. Because in the embedding space, Postgres and database are semantically similar concepts. So we can find these semantically similar concepts even if there's no exact word for them. Same thing with translations, right? I can search in Spanish, and then I'll get back results, even though you gave me English titles and descriptions, right? Because in the
That
embedding space, the Spanish word for database is very close to the English word for database.
that is fascinating. So in this case, you're using a service, you're calling Azure OpenAI embedding service, passing it the text, and it's giving you back the embeddings. There's no
Mhm.
way to do that locally. Do we need to use a service for that? We can't just like right click on a database and say generate embeddings.
So yeah, you actually can do it locally now using the Olama models. If you have experimented with Olama models at all, there are a few ones here. I've used Nomic for embedding. You need an embedding model. So an embedding model isn't the same as a large language model, right? The point of an embedding model is to output an embedding. So this is one local embedding model that I've used, and it works. It works pretty well. So I do have a RAG app where I have used this one for embedding everything. But here's the thing is that then you have to then use that same model when you're doing the search. So whatever model you use, you have to be consistent because they all have completely different embedding spaces, right? It's like different brains. So whoever's embedding brain you use the first time, that is what you have to use when you're doing a search.
And if we had used something like Azure's vector search as the database, is vector search a database?
Are you talking about Azure AI search?
Azure AI search?
So Azure AI Search is a search engine that supports both full text search using, something like Lucene, which is a full text open source project, and then also using HNSW for vector search. So they'll support everything, right? So if you give it vectors, it'll search those vectors efficiently. If you give it text, it'll search that text efficiently. Just using best in class for both text and vectors. Right, because
Gotcha.
there's
So
just
you
very
could do it
different
either
algorithms.
you could do it either way, but for the embeddings, if you want semantically similar terms, you have to generate those embeddings. And for that, you either need to use a hosted model or you need to use a local model. and then you need to use that same model when you actually query the embeddings in the RAG process. Is that,
Mhm,
have
mhm.
that right? Okay.
Yeah, and one thing you can do, and this is what I did in another, in a different repo, is that I just made multiple columns, right? So I made a column for one model and then a column for another model, and that way I can just kind of switch between them. So I can switch between my Nomic embeddings and I can switch between my ADA002 OpenAI embeddings. And so that's an option as well. Like if you wanted to be able to, easily switch between your local model and your hosted model so that you have more options, you would just want to add multiple columns to your table. So one for each of the models.
So one last question here then. If we had a data set that was changing like transactionally, like let's say
Mhm.
every time a YouTube video is posted, this database gets updated, we need to generate the embeddings when we do the insert of that new data. That needs to then become a part of the flow.
Yeah, that's right. So in that case, you'd probably want to use a database trigger. I haven't implemented that in Postgres myself, but I believe they have something like triggers. And so basically, whenever this thing happens, whenever a new row gets added, you want to make sure that you compute an embedding for it. Azure Postgres even has like a special extension that will do that for you. It's like the Azure AI extension for Azure Postgres, but that will only work in production right now.
We just
So
automatically create the embedding for you.
I think that's how it works. But to get something working locally, and this is on my to-do list to figure out, is you'd want a trigger is like, oh, okay, there's a new row. Let's go ahead and update it.
Yeah,
Um,
it's super interesting. I didn't know any of that was the case. I mean, I knew a little bit about embeddings, but not that much. So that's interesting. It also seems like, and I'll let you get back to the code, that if you had a database that was getting updated a lot, that you could end up calling that API a lot for the embeddings, and that could be expensive.
That's true. Yeah, the embedding APIs are not as pricey as the other ones, but of course, anytime you're calling an API, it can be pricey. So it's definitely something to keep in mind. That's also why some people are experimenting with the smaller models and the local models for embeddings. And that's also why Azure Postgres, they have another extension called Azure Local AI, which does an embedding using a local model that's actually stored on the Postgres machine. And so that way you're not paying, you're not paying for the cost of going out to, Azure AI.
Oh, all right. So tons of options here,
Yeah.
but we're so early on with AI. It feels like we're all just kind of like riding right on the rails.
Yeah, yeah. I mean, that's why it can be a little tricky because there are so many options. You have to figure out, what it is you're gonna do. All right. So since we were talking about vectors, let's just go straight to doing a vector search. Since we're there now. So let's see. So we did this. We used the like. We actually got a bunch of good results with the like, just because I think you talk about Python a fair bit on the channel, which is great.
Maybe too
Go
much
for
based on
Python.
this query. So
Uh,
it return it's so okay, so it's just returned all the data, but it's just doing a like search. This is like just a plain text search here.
yeah, let's actually limit 10. Yeah, this is really, really basic. Like it's not doing any sort of ranking or anything like that. Now what we also can use is full text search, right? Let me see if I can get it to search Postgres table, because Postgres does have built-in full text search. It's called like 2TS vector, something like that. Uh, all right, there we go. So this is using the Postgres full text search that's built in. And this is a fair bit fancier, right? This is, and it's funny, as you see, it's called vector. So it's actually doing something somewhat similar where it's like figuring out, it's looking at all the words that are in, your text and looking at their frequency and then saying like, okay, well, this word is like particularly frequent compared to this other word, and it's kind of building these like frequency stats, and then it's comparing to figure out like, oh, okay, which of them matches is the best, and let's do some ranking too. So here we can try this search
Is
next.
that built in, Pamela, that the
Yeah,
TS
so that one
vector?
is
Okay.
straight up built into Postgres, so I didn't have to install any extension to do it. and Copilot just knew about it. So there, once again, we get nice results. And I would actually say these results look like a little better, because you see how like immediate, like if you kind of compare, let's compare these ones here. Refactoring Python code, effortless Python. I guess they're similar, but I feel like maybe they're pretty similar.
It's like the first one didn't find refactoring Python code. The second one did.
Oh yeah, refactoring's not on there. Well, I am limiting to 10. So that's part of it. But yeah, so it's debatable which of those is better. We can get even fancier with the full text search. What I do is I just like to look at the pgvector repo, actually the pgvector Python repo, because it has all these great examples, and that's where I get a lot of good ideas from. So let me do this one. Okay, so this has like a nice, I'm just gonna grab this one and try out this full text search. Okay, so this one's a little bit fancier. So we're gonna go from videos, and let me just change these to match our schema, because we're here. I'm just gonna look at this. I'll just look at the description for this one for simplicity. But this one has order by TS rank CD, and this one didn't have the order by. So I think that this is going to end up being a little better in terms of the ranking, right? Because it's important that we not just get the good results, but that the best results should be in like the top 5 or the top 10. Because I was saying at the beginning is that you don't want to send too much to an LLM. You want to be able to limit what gets sent. Let me limit 10. Okay. Let's try this again. All right. And I need to learn how to how do I just automatically comment lines of code? I figured you could tell me that.
Are you on a Mac?
Yeah.
Yeah, it's command and then the backslash, whatever that is. So like,
oh, nice.
Yeah, just gotta pretend you're doing JavaScript.
Wow.
I assume that's where the slash
that's why it's backslash.
Yeah.
Okay. All right, let's see. Syntax error. Oh yeah, because it's not. We didn't send in the query. So here we go. There's the question. Okay. All right.
Pamela, as you press enter here and run this, quick question: like, how do you know all this stuff? Like, this is remarkable to watch, but like, how do you know to use TS rank CD and TS vector, and where does this come from?
Yeah, that's a good question. Well, one thing that always helps is to force myself to learn something by giving a presentation about it. So for pgvector, I gave a talk at this year's POSET, which is a conference about Postgres. So this is my talk, pgvector for Python developers.
Did you draw that?
Illustrations? Yes, I like to hand illustrate. Yeah, and yeah. So if you want to dig deep, there's also a recording of this on YouTube. So that was a really great opportunity to dig deep. I got really into it, and my mom was visiting at the time, and I managed to get her to nerd out really hard on it too. And we were even like looking at the pgvector source code together. And actually, the pgvector source code is very readable, even though it's like C, and I don't really program in C very much, but it's very readable source code. So yeah, so that's like one way is just like, fake it till you make it. Just sign up to teach other people about it.
That's what we're all doing out here, y'all. Just faking it until we make it. But link in video description for this YouTube video if you want to learn more about pgvector. Awesome.
Yeah. And then the great thing is that the pgvector, repo does have so many nice examples. So basically I've looked through all the examples to see what I can learn from them. All right. So here I need to print out, okay, I'm going to print out the title this time. Okay. All right. So this time, setting up VS Code for Python beginners. So that's a really nice result, right? These all look really nice results. So I think I
started with Python and VS Code. Yeah. I would say like, those are like the canonical Python videos. That's a pretty good result.
Yeah. So that's what I wanted to show is that before we do that jump to vector embeddings, we want to do as much as we can with full text and see what kind of results we can get from that. Now, remember, we're still using that really basic question just a single word Python. Now that we're using full text search, we should be able to, maybe start adding more words to it, but let's see how that changes the result. Okay, so it didn't like, I wonder if it's because, let's go line 43. All right, let's just, oh wait, you told me how to do it. Okay, can splash, there we go. All right, there we go. So the results aren't quite as good this time because we've got this distracting word videos. And so now it's ranking things a little bit differently. Videos like I want to learn Python. Give me videos, right? Like this is actually what a question from a user is going to look like the most. And that one we got 0 results. So it didn't do so well about that, right? So we could probably, work with the full text search more to see how we could get it to work better with these questions. But this is something we need to keep in mind, is that when we're making RAG applications, we're actually getting full questions from users. Those questions are long, they've got punctuation, they've got typos, they've got lots of distracting words in it.
Yeah.
So we need an approach that's going to work well for real, legit questions. So let's try embeddings and see what it looks like with embeddings. The funny thing is we still haven't even gone to the LLM yet, right? But this is a big thing, is that when you're doing RAG, a lot of it is about the retrieval. If you can do good retrieval, then the LLM is very happy to do stuff for you, to answer correctly for you. So if you can get that retrieval down, your RAG should generally be pretty high quality. All right, so
yeah, I agree with that. And Pamela, I've noticed, at least on my own, that my tendency is to give the model a bunch of junk and be like, hey, fix this, essentially. And that just is not, you don't get good results that way. But as an engineer, it's just like, well, the promise of AI was it's going to do the job for me. And it's like, it's not going to do the job for you. It's going to do some of the job for you.
Yeah. That's right. So you really have to help it out by really working on your retrieval step. I need to not make up column names. Okay. Let's try this. All right. So this is where things get tricky, actually, is that we need an embedding. We didn't make an embedding. So
you have to turn their phrase into an embedding.
Yes. So that means we need an LLM. So when it comes to LLMs, we have a lot of options. So we could use openai.com. We could use Azure OpenAI. We could use Ollama. We could use Azure AI model catalog models. We could use GitHub marketplace models. That's what we're going to use today, just because it's the easiest to get started with, at least once you're off the wait list. There is currently a wait list, but once you're off the wait list, it's very easy to get started with, and it's super fun. So here are all the
use the same model that we created the embeddings with, right?
We do, yeah. So the embed, I'll say, like, if we look at my thing here, I used Azure OpenAI, but oh, you can't even tell what model I use. I use the text embedding 3.
Okay.
It has a different name because this is the deployment name, but I did use text embedding 3, and that is available on this one. I use text embedding 3 small. That is available on GitHub models, so we can go ahead and use it here.
Is small faster than large?
It should be faster, and it's generally going to make smaller. So they added these new embedding models that range now from like 256 to maybe it's like 4092 in terms of how long those lists of numbers are. And it's pretty exciting because they claim that even at 256, that this model can encode does just as well in terms of encoding information as the previous ADA002 model, which has 1024 dimensions. So that if you look at the blog post, like, they compare the quality, but they're saying even at the smaller dimensions, this embedding model is encoding just as much similarity information as the previous model that was larger. Okay, so what we can do is we click on these in the marketplace, and then you can pick, your language. Obviously, we'll do Python. And then here, it only has one SDK option right now. It's the Azure AI Inference SDK. So we'll just go ahead and use that SDK. So you can see here is the package name. So I'll go back to my file here, right? And add on that package. And let me
I like how
go.
Copilot just kind of knows.
No, Copilot, I have an extension that shows me the latest version numbers.
Well, when you went to go type Azure AI Inference, it was like it just
Oh, yeah.
for a second there, the ghost text was like, I don't know. I think you probably want this.
Yeah, what did it actually say
I
here?
swear it did. Hit it.
Now it wants fast API.
Now, yeah.
Let's see. So we've got that. So that's installed. Okay, great. So then we can go ahead and we're going to bring in the imports. I'm going to stick them at the top. Stick in there. And then this is kind of the setup. So we can put that at the top to set up GitHub models. Okay, yeah, I want to put that comment there. Okay, so this is the endpoint where it's going to hit up. This is the model name we're using, and this is basically our password. This is the GitHub token, and if you're in a GitHub code space, this already exists.
That's super nice. No managing tokens. Magic.
If you're not in GitHub code space, you can still use it, but you have to go and generate the token and export it in your environment. But if you're in a GitHub code space, it's already there. It's super cool.
That's a luxury.
All right, and then we're just going to copy and paste their code. And let's see. So we make an embeddings client. There's the endpoint. There's the credential. We embed. All right. So what we're going to embed is just the question, right? That's our variable name. And there's the model name. All right. Okay. So now we need to get back the actual embedding from that response. And this is where Copilot is just making stuff up. So luckily I know where it's stored. It's there. So it's in the data list. It's 0.embedding, because you can embed multiple, you can do batch embeddings. You can send in multiple strings. In this case, I'm only sending in one. So I'm just grabbing the first embedding out. So now I have that. And that is a list of floating point numbers. It is a Python list. I'll go ahead and run this, but we're going to get an error. Yeah, so it doesn't like it. Well, part of it is that it doesn't like that we send in the question. All right, let's change this to embedding. Okay, and it still doesn't like it. Now, this is just a tricky aspect of using the PG vector extension, is that it actually expects you to pass in a NumPy array. So we have to turn our embedding into a NumPy array. And you can see this
tricky.
like, yeah, this part, this is the trickiest and it always messes me up. We can see that in, let me see, just if we look at the, like just the basic examples on here, let's go Psycho PG2, right? And so see how it says here, embedding equals NumPy array, and then they put the list in that constructor, yeah.
Man, that's tricky. It would be nice if the error said that, but error messages are hard. I'm curious, if you ask Copilot, will it?
Oh yeah, do you want to do explain? I wonder if they'll
Yeah.
figure it out. This is like the #1 issue asked in their repo too.
Just curious if it can get it.
And here's the other interesting thing. So Postgres, you can override operators. And the funny thing is that this operator, I think, is the same operator that PostGIS uses for comparing two latitude, longitude points. So that's why like it can get particularly confused with operator overrides, where sometimes you have to kind of tell it like, no, like this is the exact operator I want to use, right? So let's see. So yeah, it's not sure which extension we're trying to use, right?
It doesn't know. Then it wants you to cast the embedding to the appropriate type, which is not it. So no, yeah, interesting.
Yeah, it's a tricky thing because it's also confused about whether we're using cube or whether we're using vector, right? And I think also the PostGIS is another one it could be. So, I don't blame it. It's
yeah, that was a tough one. I would have been surprised if it had got that one.
Let's see. Okay, no, we'll just import NumPy as NP. Thank you. Okay. All right, now let's see if we did this. Okay, and then the final issue is, okay. I was saying, this is the hardest part, and I always mess up on this. So what let's just go ahead and take their exact code. And let's see, that's looking pretty, that does look really similar. Let's see, we're using this. Dun, dun, dun. Oh, I bet let's see. Aha, I know what we haven't done. Okay. All right. We'll get the same error. Okay, here's the issue. We have to register the types. When we're using custom types with Postgres, with the CyclePG adapter, we need to register them somehow. So this PG vector Python has this function which tells you to use if you read the docs. So we need to import that, and then we're gonna go down here, and this is like a good place to I think we just do register vector on the connection. That seems right. That's what it does here. Okay. So now I think we've created the extension that exists. We've registered the vector, and that's really registering the type, so it understands how it uses operators with certain types. All right, and now, moment of truth. Aha, this is fine. It says different vector dimensions 1536 and 256. So
you like that error a lot more, though.
Yeah. The default dimensions for text embedding 3 is actually, I guess, 1536. So we need to go ahead and pass in, like if you look at this IntelliSense, are we going to get the IntelliSense? No, maybe not. But we need to pass in dimensions to here. So since I use 256, like if we look back at here, I use 256.
Yeah.
I need to use 256 when I generate this new embedding. So not only do we need to use the same embedding model, we need to use the same number of dimensions.
Interesting. Well, that was a lot. That error message was much more helpful.
Yes. Yeah, maybe we can try and improve the PG vector ones. All right, so here we go. Let me go ahead and comment out the other ones so that we only see the vector results so that we can take a look. Okay, so these are the vector results, and these look really good. These are ones that we saw before, right? That we liked a lot.
Right. Very nice.
And let's see if we can do, now we should be able to do any sort of question, right? Like, I really want to learn Python. Show me now, please. Okay.
Is that how you talk to AI? That's how I talk. I do the same thing.
Yeah.
Top 5 Python interview questions.
Oh, because Rob,
interesting.
Did you do that one? Because I did say Burke in here.
No, I didn't. But
Okay.
That's interesting that it pulled that one back first, because it's like picking up on the urgency of
yeah.
Yeah.
Okay, so now we've seen vector search, and now you might be thinking like, oh, vector search, we just only use vector search. But vector search isn't going to work for everything. Like, it doesn't do very good if we're looking for like numbers, proper names, that sort of thing, right? Like, it'll think that Burke is semantically similar to, Reynolds or something, right? So generally the best practice is to use hybrid search if you can do it well. And there is an example for that in the PG vector Python repo, this hybrid search with RF. So here you can see that it does the vector search, right? This is the vector search that we just did. It does the keyword search, and that's the one we did before that. That was pretty good. And then it merges the results together. And this is
wow.
Yeah, this is it's an algorithm. It's called reciprocal rank fusion, but it basically just looks at how often each one is appearing and what its rank is in each of the lists, so that if it does like appear in both the vector results and the keyword search results, and it's like number 1 in there and number 2 in the other one, like it just comes up with these merged ranks for them, and then merges them based off of their positions in each of those lists.
That's a serious query right there. That's common table expressions and whatever coalesce, whatever algorithm that was that you said.
Yeah, reciprocal rank fusion. And this is actually what's used by, like, Azure AI Search also uses reciprocal rank fusion. It's a very common algorithm to use for merging results. So that works pretty well. That's actually what I use in my other RAG on Postgres apps. So that's what you want to consider, is using a hybrid search to get the best of both worlds. And then if you want to take it one step farther, there's another example in here where they use a re-ranking model. So a re-ranking model, let me find
I've
it
heard
here.
of this. I've heard this phrase before.
Yeah. So a re-ranking model is a model that is optimized for re-ranking. And it literally has like been like trained by humans, where humans, like we give humans a bunch of, like 10 search results and a user query. And we say, hey, can you rank these search results according to the user query? Which one is best? So imagine you had like lots and lots of data like that of what is the best ranking for a particular query. You can train a model based on that. So the model learns, to be like the human, and learns like, oh, okay, for this sort of user query, I would want to rank things like this. So it is only for re-ranking. It's only as the last step in the process to apply to just like your top 10.
So you do the search, you get the results, and you give it to the re-ranking model and say, hey, here's the results I got. Here's the query I gave. Now
Mhm.
re-rank based on that.
Exactly. Yep. So here's the query, here's the item, and re-rank, predict the rank, however you want to think of it. And and then you get back the results with scores, and you can sort according to the predicted rank.
Wow. Okay. That was good. I feel like I'm understanding concepts that I keep hearing and I don't know what they are, but I use them like I know what they are, but now I know what they are. Thank you.
Yeah. So the tricky thing here, though, is that this is running a model, and you don't want to just casually run a model like just on any old server. So you would probably want to, set up dedicated hardware for it, or use a hosted re-ranking model somewhere. So Azure AI Search has their own re-ranking model, which is literally the model that Bing uses. So it's pretty good. But I think there are also hosted re-ranking models, or hopefully will be soon, so that could be an option for you as well.
But in
Okay.
this case, we're letting Postgres do that with the extension and the coalesce.
It's two different steps. You ideally would do RRF and then re-rank.
Oh, you would do both.
Yeah, ideally you would do both. Like imagine using RRF to get like your top like 20, and then doing the re-ranking and then sending those, top 10 to the LM.
Okay, so we are doing a lot of work here to get this data in the best possible shape for the model. And
Mhm.
that's super important, I take it.
Yeah. So you'll get the best results if you can do everything. You can do hybrid, and then with the RRF, and then you can do the re-ranking. That's generally how we get best results. There's a great blog post that the AI search team put out where they did all these experiments. So at least for the documents that they looked at, and with using AI search, they got the best results when they used hybrid plus semantic ranker.
Wow.
And it did vary per like query type. Where's their query? Oh, they don't have the query types one on here, but oh yeah, here it is. Yeah. So, there's something like keyword queries actually obviously do the best with the keyword results, right? But across the board, if you have hybrid plus semantic ranker, you're just going to get the best results across the board. So there you go. So when you're setting up RAG, just keep this in mind, and test your searches, see how good of results you're using, and see what options you have for whatever retrieval mechanism you're using.
Gotcha. All right.
Okay.
So where are we?
Well, we should send these to the LLM, right?
Wait. Do we want to re-rank? Are we going to re-rank them or?
I don't. I actually have never re-ranked myself. we
Okay.
could
So,
we could try that, yeah.
but in an
I
ideal scenario, we would
Yeah,
do that. Are
in
you
an
going to do
ideal scenario, yeah.
the hybrid here of
Yeah, we can
the?
go ahead and bring the hybrid. Yeah, we can do that. Let's go bring the hybrid in. Let's see. So let's go RF. Okay, we bring the hybrid in. Blah blah blah. You just want to see this big SQL, don't you? All right. So
I
here we
do.
go.
Yeah. It's
Yeah.
glorious. Look at it.
Let's see. So we're gonna do a new execute. Okay, and so now we need to go through and just fix these up so that they're referring to the right schema. So this is going to be coming from videos, and this I'm just going to do a description. Ideally, I would throw title in there too, but we're just going to do description for now. Okay, and then it does the RF. Okay, and that one just gets back the IDs. And let's see, then we're going to have a parentheses. And then get the results. Okay, results. Okay, and so that just gets back our ID. So then let's fetch the videos by ID. Yeah, there we go. Okay. All right, and that's going to do ID, title, description. All right. Okay, let's try this out. Okay, of course, syntax error. All right. Yeah, embedding, because I when you're passing in these keyword arguments, you do need to actually pass them in, right? So here we're going to pass in the variables that the query is using. So query is going to be question. Embedding is embedding. K is a number that is part of the RF algorithm. And I know Azure AI Search uses 60, and I think this example uses 62. Yeah, so everybody just uses 60. So we're going to use 60 because it seems to work the best for RF.
It's
So there
just
we
the
go.
magic number. Yeah.
There you go. All right. So now we have done. These are our merged results here.
Interesting. And are they ranked? Are they in order of importance?
These ones are in order. Yeah, because we got the, this here is ordered by score, right? So this is the RRF score, the fuse score. And then this is ordered by score. And remember, this is for our ridiculous question where they wanted
Really want to learn Python? Show me now, please.
videos about databases, please. Okay. Okay, so now this time we're getting
Ask your database to query itself. Copilot.
Yeah.
We don't do a lot on databases.
So data structures. So that's the interesting thing. This is something you have to keep in mind. This is why we like semantic ranker, is that according to the vector search linked list, it's a data structure, which is similar to a database, right? So this is the kind of thing that happens once you start bringing in vector search, is that you can get this noise, right?
The other thing here is that it's also looking at description. Is it not going to do
This
the
one's
search?
only looking at description. Yeah, I wonder. Okay, how good?
Yeah, because so we don't know.
Yeah,
It might actually be in the description.
Let's see. Copilot. Can you add title to this?
Just do inline chat. Just do trigger the inline chat and see what it does. Like just a command I.
Command I. Okay, I'm pro. Is that nope? Control I. Nope.
Does it still have focus?
Try it again. There we go. Okay.
Yeah, and see if it'll do it in line there.
All right. Add title to this title field to this query.
Inline chat's pretty good at this, like iterating over mostly.
Let's see.
Already correct.
Oh no. So the one thing is that I should have been more specific. I wanted to actually add it not to like the select, but to the add title to the where order, right? I wanted to add it to the full text search part. Okay, so
is that right?
No. I think let's just take a look at what we did earlier with TS vector. So that's okay. So here we just did this. I think this is a way to join strings together. So I think we can just go like this. Title, plain to this query. Okay, and then let's try this. I feel like we should be able to use like a variable for this or something, but
we'll do that later.
Yeah.
We'll come back to it.
So I made the change and the results look pretty similar. They look the same. So I think
we're not looking at the description anymore. We're looking at the title or the description because we're concatenating.
We're looking at title and description. Yeah. Yeah. So I think just what happened here is that, this linked list result is ranking really highly with, with the vector search. But
I'm wondering if like on that one, is database actually in the description for that?
Oh, maybe. Yeah. Let's just go ahead and look at the descriptions too. And I'll just do the first two to make it easy. Okay, let's run this. All right.
It's the first one.
So here's the link list. And it's a diagram, more info.
No, I don't see anything. Link is there, but I
Yeah.
don't see anything about databases.
Yep. And then let's look at our query. Now, I would assume like if we let's take it out the please. Let's see what our results are looking like. Okay, so that got better results. So maybe it was that please that really, threw it off there. And actually that's why a lot of times what I do, so this I called this simple rag, right? Advanced rag, I'll just show you what advanced rag would be, is that we, get question from user, and then 2, use LLM to turn question into a good search query. So this is what I always do now. I don't trust simple rag because the user's questions can be too noisy. So we pretty much always will use to have this query rewriting step that will use the LLM to turn the question into a good search query, because that'll ditch like little words that just aren't useful, right?
Yeah. So you're asking the LLM, like, clean this up. I got this query, clean this up.
Yeah.
I use this for, I did this the other day on an email I'd written. I was like, and I just passed it to Copilot. I was like, clean this up, please. And it did a pretty good job.
Yeah. So LMs are very good at cleaning. So that would definitely help us with these, with these searches. Because then when we do, just videos about databases, which is a pretty good query, then, then I think the results, we'll take a look at the results and see. I think the results are pretty good. So, MongoDB, database, Ruby, is fairly related to databases. And then we get the link list one.
Okay, so it's improving a little bit. Are we ready to send this off to, I guess what's the next step is to just ask the AI. Shoot. So, all right, so we have the question, we have this data. Now we're going to pass it to the AI and say what?
Yeah, let's do that. All right. So first, I just want to make a string that has the results, right? So this is fine. Or we could do it like, you can do it any sort of, you could send JSON, formatted. We could do Markdown. LLMs like Markdown a lot too. So we'll just do Markdown. So now we've got the formatted results that have the title and description in them. And now we need to send to an LLM. So let's go back to GitHub Marketplace models and we'll pick an LLM. I use GPT-4o a lot lately. It's pretty good. So we'll click on Get Started here. Python, Azure AI Inference SDK, and that we've already got installed. So we'll go and add these imports to the top. Some of them we might already have, but a couple are new. Okay, we'll keep those new ones. And we have to make a chat completions client this time. So I'm just going to copy paste all of that and go down here. Okay. And for the model name, I'm just going to pass in GPT-4o here. Oh, and the temperature. Okay, temperature of 1 is really high. I would
That's
not
going to be like that's going to be some WordPress blog spam right there. I noticed this, that if you crank the temperature all the way up, it's literally nonsense that comes back from the
If you
LLM.
do it, so you can actually go up to 2 now, at least with like GPT-4o, and oh my gosh, at 2, it really, really is nonsense. For RAG, I typically use 0.3. That's pretty good according to my evaluations. Okay.
0.3. And so I guess for those watching, the temperature is just the randomness that you're tolerating from the model, to being extremely stochastic and 0 being extremely predictable.
Yeah, because every time when the model's picking the next word, it has like, a bunch of different tokens it can pick, and they each have probabilities assigned. And if you do 0, it's always going to do the most likely one. But if you do 0.3, sometimes it's not going to be the very most likely one. That's
So can we say we're tweaking the creativity of the model by tweaking the temperature, or is that inaccurate?
Yeah, I think that's fine to say it's the creativity. I often say that, but then people will ask like, "Oh, how does it really work?" So how it really works is that it's a next word predictor, and each time it has a bunch of next words it could predict, and they've got probabilities assigned. And when you increase the temperature, it widens the possible probabilities that it's willing to
I
pick from.
feel like that's kind of what humans do too, though. Like if you're being creative, there's sort of like an obvious answer. Like
Yeah.
just say you were going to write a story. There's an obvious sort of boring way that you could write it, but then you pick the more, you try to think of better ways to say things or different ways to. I don't know. It seems like it could be similar to human
Mhm.
creativity.
Yeah, I think it probably is. It's yet to be seen exactly how similar we are to LLMs, whether we're really just LLMs or not. But we'll find out.
It's appearing very much more and more every day like we just are. But yeah, we shall see.
All
All right.
right, so we need to pass in a system message and a user message. So system message, we're gonna say you must answer user question according to sources. Say you don't know. If you can't find answer in sources, um, cite the title of each video, which will be a markdown heading, right? So I'm trying to give it as much information about like how the sources are formatted and how it should cite it. And you could get much more precise with how you want your citations depending on what you need.
I think it's interesting. You have to tell models that it's okay to say that you don't know. If you don't know, just say you don't know.
Yeah, you really have to, to do that because LLMs like to be really helpful because they're trained on the internet, which is full of lots of helpful people trying to answer things, right? And so you have to really persuade it to say it doesn't know. And generally, that's actually the biggest problem I have with the smaller language models. When I use them with RAG, they're much more likely to not pay attention to the system prompt, basically, like, and answer it regardless, or not cite things properly and all that stuff. So I think you really need very good models for doing RAG. I have had success recently with the Llama 3 local model. So our local models are getting better, but you do need pretty good performance if you're going to do RAG.
This is another way that models are like human beings, that we admitting that you don't know something if you don't know. It's so hard. It's hard.
Yeah, I mean, I have a blog. I mean, that's literally a blog post. I'm getting
Oh, you've
LLM.
already written that blog post.
I well, about LLMs, not about humans yet, but specifically about evaluation because I wrote a whole evaluation flow in order to determine whether my app was properly admitting it didn't know. So I have like a whole set of like metrics, the don't knowness metric that I have that I use to figure it out, right? So then I can do evaluations and measure the don't knowness of each of them. And the interesting thing is that I tried all sorts of prompts, but really you get the best improvements just by moving to a more powerful model, right? So GPT-3.5, not so great. GPT-4 gets a lot better, right?
So the more recent the model, the more modern the model, the more likely the model is to say I don't know when it doesn't know.
I think it might also have to do with just particularly way it's been trained, right? Like it's like our like HF training, right? But I mean, the basic point is that whatever you're doing, you should keep this in mind for RAG, and you should ideally evaluate it to make sure that it is saying it doesn't know. All right,
Very cool.
so
Yeah, I ran into this issue building a Copilot extension where I was having it generate tutoring on lines of code and put an annotation out to the side. And I would say, if you don't have any recommendations, just say no recommendations. And it just can't, right? It's like all import statements should be at the top, even when they're at the top. Like, hey,
yeah, and the other thing you can try there is few shot examples, right? So we haven't talked about few shot examples here, but we have other techniques like few shot examples and function calling. Those techniques are all still relevant for RAG, and you can definitely improve your results when when you use those techniques, right? So that could be something that could help, with that.
I should
Uh,
try that. I was because I'm at the moment I'm kind of stuck with it. It always does that. I cannot get it to stop and just
which
say
model is this?
it's GitHub Copilot, which is now 4.0 for all chat. Yeah.
Okay. Yeah, so you could try a few shots to see if that helps it.
All
Okay,
right.
so here is our system message. And then for the user message, I pass in the question plus the formatted results.
Now, you didn't
Mhm.
delimit the results with like triple backticks or anything. Like how I've seen that model before where it's like you must answer user question according to sources, which is delimited by triple backticks. And then triple backticks, do you find that that doesn't matter in the prompt
I mean,
engineering?
we can write sources. Usually it's pretty good at knowing about the sources. So,
Okay.
we can write sources here. It figures it out.
I've seen
The
so much
most
guidance on prompt engineering, and some of it I'm like, some of it works and some of it doesn't seem to make a difference.
Yeah, so that's just saying, like, you do need to do prompt engineering if you need your citations to be really precisely formatted, right? So if I want to say cite the title with you inside square bracket, so we'll say, inside square brackets, uh, the title of each video will be a markdown heading, right? So we can definitely get more precise with describing how the sources are formatted and how we want our citations. It just depends on the application we're building and what we need from it.
All right, so we're close here.
Yeah, let's just do, here we go. All right. And then I'm going to say print answer. Okay. All right, here
All
we
right,
go.
what does it say?
So it says, based on the provided sources, here are the videos related to databases. And look how it picked out the ones that were
Wow.
truly related databases. So in a way, our LLM is also acting as a bit of a ranker because we did pass it in like a fair number of things. We passed it in 10 results, which is actually quite a few. I normally only pass in 3 or 5, but we passed it in a bunch of results and it could tell, it knows which of these are
Can you
really
go back
related.
to those results? Let me just see. Like, I just want to validate for a second. So, yes, yes, Ruby, no, 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 no,
I
no.
think, wait, we might have some,
Wow.
let's see, print results. If we still have the vector results. Okay. We gotta,
Yeah,
let
I've
me,
seen stuff in there twice.
yeah. Okay. So let's see what the true top results were. All right.
So,
So
linked lists.
the
Yep.
top one is still linked list. Yeah. MongoDB.
And it did not fall for that. Okay, easiest way. And then ask, yeah, I mean, that's spot on, right? That is just the two results that have to do with databases.
Hmm. Yeah, so that's good. So that would be another approach is that, you can pass in more. And actually, in this case, we only did 5. That's all we passed in is 5. So you can pass in more as long as it fits inside the context window. So every model has a context window, which is how many tokens you're allowed to send to it. So, we could pass in as much information fits in the context window, but keep in mind also a lot of times when we do RAG, we're doing full conversation. So we also want to be passing in like the
The
conversation
history. Yeah.
history too, because it has more context. So that limits how much, we want to send in. So 5 is a good amount to explain. And the LLM did a good job of picking out like, oh, okay, of these are the ones related to databases. All right, let's try. All right, what question do you want to ask, Burke?
Oh, uh, 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 oh man. So I can ask anything, right?
Yeah.
So ask it this: how many of these videos are YouTube Shorts?
Oh, this is a great question to ask because it's not a great question for this code, but we can talk
Right.
about
It
it.
doesn't
So
because it doesn't know how long they are.
yeah. So if you're going to ask, this is what I call like data analysis queries or aggregate queries. If you're trying to actually, ask these sort of aggregate queries where you need to actually really be able to look at the whole database, it's not going to work with this flow. What I would do in that case is do like an NLP to SQL sort of thing where, we actually say, hey, generate the SQL query that will answer this question. And
Yeah.
then we execute that SQL query and then do our final step. And I do a little bit of that in my rag, but this is sort of thing I would only use it for like an internal facing thing because I do get worried about generating SQL and executing SQL for just arbitrary users of a website. But for like an internal tool, I think that can be really, really helpful. The other thing you can do is like if it's like a smaller bit of data, you could actually have have the LM write like pandas code or numpy code because it's really good at writing pandas code, right? and then and then execute the pandas code. That works if it's like something where you've got like a CSV uploaded, right? And you like it can load it in.
I mean, ideally,
So
what it would say here is, I don't know how long the videos are, so I cannot tell you that, right? Like if you were going to ask a human being and you gave them this data, or they may look at it and say, these videos say that they're shorts in the description, so they obviously are. But if I knew how long each video was, I could tell you for sure, but I don't know that.
yeah, well, it says here both are marked with shorts. So I think it did a good
Okay.
job based off of what we gave it. But this flow is never going to be able to answer a question that requires looking at the whole database, because this flow is only getting the top 5, top 10 results. So
Oh,
if
that's
you
right. So it's like the how many is not a really good question.
Yeah, I think so. I'm saying, like, if you do want this type of RAG, what you probably want to do is actually ask the LLM to generate SQL and just straight up execute that SQL. So it's a valid kind of RAG, but it's a different thing. It's a different approach.
Gotcha. So this is best for questions like, show me videos on this content.
Yeah, or what can we learn from the description? Like, does VS Code support Python, right? So we might have we only have titles and descriptions, but I'm curious what it'll say if we ask it, a question like this. Yes, VS
Yes.
Code supports Python, right? So it can even answer a question based off of just what it's seen in the descriptions. But yeah, given that we've got just video titles and descriptions, this would be just a way to
Ask it this.
have people search things.
Ask it this. Does GitHub Copilot support extensions?
All right. Okay, so it says they don't mention explicitly, but they do discuss how to install Copilot. It just says it's not provided. So it's done a pretty good job saying
Interesting.
it doesn't know.
Because I'm asking that question because I happen to know that there's a video called Asking Your Database to Query Itself. I don't know
Mhm.
what the description on that video is because that is specifically about how to build Copilot extensions. Let me just check the
That's the one
source
that's,
data.
yeah, query your database. So we just didn't see that. Let's try like a higher number of results and seeing if we can get it in the higher number of results. Mhm. Okay, let's see. Yeah, I didn't find it that time yet either.
Yeah, so the description is asking Copilot to help with database queries is an informative. You can only go so far, but what if it aware of your database schema? In this video, Rob Connery shows you the new GitHub Copilot extensions for VS
Hmm.
Code, which allow you to create your very own chat participant.
So there, the problem is that we just didn't find that result. I think if we found that result, then it probably would have been able to answer. Like, we can just keep on
It
reading
wasn't
right
even
here.
in the source.
Yeah. So this is what I tell people: when you're debugging RAG, you have to first check to see, is the issue with the retrieval or is the issue with the answer, right? Because most of the times the issue is with the retrieval.
I see. Yeah,
And
I don't see it anywhere in there.
yeah, it still didn't get it. So it's just really not finding it, right? Like, we could try, simplifying this. The problem is that title, has it's I think it's really favoring things that have GitHub Copilot in the title. Oh, there. This time we got it. Okay. So
Okay.
this time we have it. It's at the very bottom of it. And GitHub Copilot can be
Can it be
extended.
extended in various ways?
Yeah, yeah. I simplified the question, so it's not quite answering the same
Scroll
way.
down. Getting started with Copilot chat, PowerShell, Jupyter Notebooks.
There you go. There you go.
There it is. Yeah, although that's really the only relevant result in that. Interesting. Of
Yeah,
course, it
they kind
doesn't
of
know, like,
they
we
took
said
the
GitHub
word
Copilot
extension.
extensions.
Yeah, they took the word
Yeah.
extension, like, to be fairly abstract in this case. Like, well, there's lots of ways you can use Copilot, right?
This is very eye-opening for me because it's helping me understand how when I ask GitHub Copilot questions, it might be giving me the wrong results because of the way that I'm phrasing it. Right here,
Mhm.
we need to know that GitHub Copilot can be throwing it off, and the word extensions is real broad.
Yeah.
There's VS Code extensions, there's GitHub Copilot extensions. So maybe if we rephrased it to say, is it possible? Is it possible for me to write a custom extension for GitHub Copilot?
All right, let's try asking that. Let's see if it got the result. The thing is that I don't think that we have that video there. Yeah, so
I,
this time the problems with the retrieval. It didn't
okay, so
retrieve
let's ask it
that
one more
video.
way. Is it possible to build a custom chat participant?
Oh, and you're trying to get rid of extension so it's not thrown off by an extension.
I'm just seeing how specific I have to be. Getting started with, did we get it that time?
Nope, we didn't get it. So
Wow.
it's just having a really hard find retrieving that one video that mentioned it. And so, part of it is that maybe you want to change that video title and description to
Yeah, no
have
kidding. Maybe that says more
more
about how
stuff
the way
in
the
it.
video is titled.
Yeah, because I don't think that video has Copilot in the title.
It doesn't.
Yeah, it doesn't. Yeah. Let's see. Extend, yeah. But these are great questions to try, because what you can see is that what really matters is that retrieval, and the retrieval is going to vary a lot based off of how someone has worded the question and about what kind of search you're using, vector search, hybrid, full text search, what kind of cleanup you're doing, right? And all of that is going to affect the quality of the answers you get out.
So I have so many other questions, Pamela. Like, how are developers supposed to even, like, you can't even test this because it's going to give you the right answer sometimes, the wrong answer other times, right? Like, but I feel like we should stop it here
Mm.
because unless there's something else you want to show folks, I feel like we've gone the distance. I understand a lot more about the concepts. We've implemented, we queried the Postgres database, did the hybrid search with embeddings, ranked that using Postgres, and then pass that off to the model to get a better answer. But I know that y'all are going to dive more into this
Mhm,
coming up,
mhm.
right?
That's right. So we do have Rag Hack on September 3rd to 16th. So not sure when this video is going out, but if it comes out before
Hopefully
the
before
end of the
then.
hackathon, yeah. So, go ahead and join us. We are going to have so many streams. So, even if it's already happened, there's all of these are going to be recorded and live streamed. So it's just how to rag with everything, right? So in every different language, not every retriever, but like so many retrievers, right? All these Azure options, talking about different kinds of rag, like graph rag, different frameworks, semantic kernel and LangChain, doing agents, doing internationalization, doing fine tuning, using different models, and finally doing evaluation to really figure out whether the results are good. And we're going to have it Spanish, Portuguese, and Chinese, which I'm super
Wow.
excited about.
That is a lot of content.
I know.
Incredible. Well, I mean, I can only imagine if I've learned this much in this hour and what an hour and 20 minutes. This is great. So, y'all, thanks for joining us today. Pamela, thank you for being here and showing us and teaching me all these concepts. This is great. I feel literally 10x what I was when it comes to RAG applications and what that even means. I can now talk somewhat intelligently about it. So, thank you so much.
Yeah, it was super fun. And if you all who are watching have any questions, or you want us to do a follow up on something like advanced drag or whatever, just go and post in the comments.
Drop in the comments, let us know. Sign up for the Hack Together for the RAG Hack. And as always, happy coding. Bye, y'all.